The first step is to prepare the TLC chamber. In order to do this, pour an acceptable solvent into a beaker. Make sure that you don't pour too much solvent because it can eventually dissolve the sample on the TLC plate, so you should have a minimal amount of solvent in the chamber. Then place the filter paper into the chamber. This is important for creating a good environment for the TLC plate to develop. Cover the TLC chamber with a watch glass in order to create a good environment for the TLC plate to develop. It's important to use a solvent system that isn't too polar or too non-polar.
Part 2 of the TLC process is making the TLC plate. Step 1, you need to draw a line in pencil on the TLC plate. Step 2, you need to take your product already dissolved in a volatile solvent, concentrated, and dot it on the line. The dot needs to be concentrated yet not too big. Step 3. Remove the watch glass from the top of the chamber and place the TLC plate in the chamber. Make sure that the TLC plate does not touch the paper in the TLC chamber. Recover. The third part of the TLC experiment involves drawing the solvent front. Uncover the TLC chamber and take out your TLC plate. Draw the line to where the solvent has ran to.
Once you develop the plate in the TLC chamber, it's important to visualize the contents and the results of the TLC. In order to do so, you use a UV lamp, because most of the separated compounds are UV active. Place the TLC plate within the UV chamber. Look into the UV chamber in order to visualize the spots on the TLC plate and mark the spots accordingly with your pencil. This will be important for analysis of the contents of the TLC.
Let's say we have a TLC plate. With 2 spots. That's the solvent front. Let's say it's 5 centimeters. Let's say that spot A traveled 4.5 centimeters and spot B traveled 3.5 centimeters. The RF value is the distance the 2 spots traveled over the solvent front distance. That's how you calculate RF.